All right, let me present and we can get going the versioning stream. So versioning, I call it like a mini work stream. I mean, I don't want to downplay its significance. In many ways, the goal of the versioning work stream is to start answering questions that will definitely need to be answered. And maybe they're being asked, maybe they're being whispered, those questions are being whispered in the corners and we're hearing whisperings, but we haven't heard anything too solid. All that is to say, we're working on kind of stuff ahead of the curve, at least a little bit, or like, at least that's our goal. In the last PR, we presented a few things, namely the beta of the merge loop operator, and we presented the zero downtime deployment and some ways of thinking about doing zero downtime deployments with merge loop. So this in this presentation, we're going to be sharing a little bit about what we've been up to. Our main objectives were to release a functional version 1 of the merge loop operator. And if you're wondering what's the merge loop operator, we're going to talk about that. Secondly, we wanted to migrate our merge loop code bases to using semantic versioning. So in the past, we had a different versioning strategy, and Sam's going to be sharing about that. And finally, we're going to be evangelizing and harmonizing the merge loop version. Make sure people understand this. That was the other thing we did in the last PI, was release this thing called, or announce this thing called the merge loop version, which is really just a way of thinking about bundling together all of the different components of merge loop behind a single number, between the APIs and the Helm releases and the individual services and so on. So complete, yay. So let's get into the progress update. Sam, can I ask you to talk about this one?
Thanks, Luis. It looks like from a ROI perspective, the lean team is also the most productive. Just kidding, but all right. Thank you. Hello, everyone. On the semantic versioning, I think all our developers took to it like fish to the water. We didn't have to do too much there. So credit to the community, especially the technical community there for adopting and following that. As I've indicated earlier in the core session, even we're following it every level, not just individual repos, but also the Helm release candidate, which is ready to go soon. Apart from that, I think the automated version, which Louis showed on PASP, maybe it's something that we can take up with the DA to see if that can be adopted across code bases as relevant. Maybe official releases like Helm, we need some intervention, but I think we can adopt this across individual service repos without issues. Can we go to the next slide, please, Louis? Maybe we can make Simeon happy by saving some time on this section. On the modular version, I think this is a work in progress. As nothing too much to add there, but this also relates to something that Michael shared and another shared in the previous meetings as well, where we have now a proposal that will have special interest groups for various APIs like the FSP interoperability API, settlement API, the third-party API, and future APIs like a reporting or a foreign exchange or cross-border currency APIs. So the goal is that this version will be a consolidation of all the APIs. For example, right now the settlements API is at 2.0, FSP API is at 1.1, the operations API is at 1.0. So we made those changes to make sure that we are adopting the standard across all the APIs and services. Is it just me or okay? Yeah, it's good. It was a blurry screen. So the version 1.1 is where we are at right now. We envisage a near future where people, modular community members, will be able to communicate saying, okay, these are the issues we are seeing in version 2.0, and everybody understands what it means. This will be a bundling of all the APIs and a bubbled up number so that it's easy instead of giving too much detail when not required. We hope that this will convey the meaning needed because whoever needs to look at the granular details, the details are still there. But this will help in understanding where we are from a high level perspective. Apart from that, the semantic versioning, we covered that is being adopted. And we also have a branching strategy based on Semver for maintenance. Lewis will cover that, I think, which we adopted later. On the release plan, there is no formal policy currently. I think there needs to be a call made. So the options are that the Mojave Foundation itself can take it up, or it can be competitive space. The goal is to ensure that the concerns of adopters and implementers are addressed and allayed in a way that they can rest assured that if there is a Helm release that is made, let's say next week, similar to a Node.js or something like an LTS release, they can stay assured that it will be supported for a fixed or a limited time. And during that time, hot fixes will be made. There is SLAs are there for response times and things like that. Currently, we are saying that there is no formal policy in place. We want to bring up the discussion so that a guidance is provided and someone steps in and we have a policy in place for this as a community. Apart from that, we have all the building blocks in place. We have the versioning practice in place. We have guidance. We have bug logging and triaging in place, and release mechanisms as well, and any other technical pieces we need are in place, but we need that policy to be made. Wanted to highlight that. Thanks, Luis. We'll follow up on Discourse if there are any questions, but I think we can move on.
Cool. All right, I think this is me. So yeah, as Sam mentioned, talking about branching strategies, one of the things that we need to consider when we're supporting multiple versions of a service within Mojave is how do we apply security updates or bug fixes to code that's already out there in the wild. At the moment, we're not really dealing with this because all of our work is done on a branch called master. And that means that all the latest changes are there on master. It's not really a problem because you're always deploying the latest thing, at least with our current kind of support model. So we need a way to apply patches and security fixes to multiple versions in the past that were released. And just a bit of a background, security patches are dependencies, or so node dependencies, most of the case for us, or Docker image updates. So if the underlying image that we built a Docker, we build a Docker image upon an underlying image or a base image. And if that had a security vulnerability, that means that vulnerability is in our image as well. So we need to make sure that we're kind of making these security patches on a regular basis so that we get the benefits of those security patches that exist in the open source community. Bug fix is something we did wrong, or something's broken that we did, or maybe a dependency that wasn't meant to break something broke something and we needed to fix that as well. So this is our proposal for a branching strategy. We did a lot of research and then we found something that looks something that looks pretty much the same as what we have. So I'm going to say these words and then I'll walk you through a picture and then you'll be like, oh, okay, I understand. That's how it works. So everyday releases under the new model that we propose are still made from master with a format x.y. And separately somewhere, we maintain a list of these supported versions. And we're not quite sure what that will look like yet. But for the list of those supported versions, we create a branch called a release branch. And that's going to have the format x.y.z. So you'll see that in the picture in a second. And when a bug fix or a security patch is made, we apply it to the code that lives on that separate release branch. And then we release from that branch. So that way we can, if we have multiple versions of something that are out there in the wild, we can apply those patches to multiple versions at the same time. So like I said, here's the picture. This is going to be much better than hearing me talk. So let's say we're on the master branch, and we've released version 1.0.0 of some service in Mojave. And after that, we released version 1.1. Everyone's happy, no worries. There was no change. There was no need to do any bug fixing or anything on version 1.0.0 because we're not supporting. We haven't said that we're supporting 1.0.0 as a supported version. And then we released version 1.2, and we've said, okay, that's going to be a supported version from now on. So we've released 1.2.0, but we've said to the community, you can expect this image to receive support from us. So just keep that in mind for security updates or fixes in the future. So now we go ahead and we keep on working. We're doing our work. We release version 2.0.0. And this is where in the past we would get in trouble because we wouldn't be able to go back and apply a fix to the older branch, or to the older release. Now let's say there's a bug fix that needs to be made, and we can apply that to our supported version on that separate branch called this release branch here for version 1.2. And we can go on a merry way. We can add a new version, version 2.1. We can call that one a supported version, and it also gets its own branch. And then let's say there was a security patch that applied to both of those images at the same time. That can then be applied to both of those release branches, and we can increment this bug fix version. So all of a sudden, we've got one update that can be applied to multiple pieces of the code at different points in time, and still be supported. So that is our proposed branching strategy. That's what it looks like, and this also lends itself very nicely to automation, which is really one of our goals. Is that we want to automate as much of this as is reasonable, to also ensure that we're not pushing malicious code and things of that nature. So the other kind of key output to talk about is
quickly. I'm sorry, Lewis. Before you go on too
certainly.
quickly, have you thought here about rebasing, given that a hotfix that you might place could actually have occurred back in code that was released as 1.10 on your diagram here, and so it applies to anything that came after that. But that given that you have these release branches, you're going to collect these over time. You could have 15 of them. You'd need to then go through and individually commit to each one of those 15 release branches this hotfix, when it would seem that by going back, rebasing this, you might have the ability to roll that forward in a more straightforward way. There'd still have to be a commitment cycle, I would think. But anyway, I just wanted to understand that it sounds like you're saying that, well, now we would have a way of addressing those releases individually. The question is there a way in which you can do this through the GitHub structure, the Git structure, that minimizes the need to go through 15, 20 different release branches and apply this patch, where it could be, something that we discovered very early, that applies very early on to the code. Yeah,
I could look into that. I'm not quite sure. I mean, I think that sounds reasonable to me. I think Adrian's also asked a question: is the proposal strictly release flow? And yeah, I don't know. I think we need to do a bit more research to really nail this down completely and make sure that we're either adhering to that proposal strictly, or we're able to do the things like the rebasing, like you recommend, Miller. So I don't know the answer to that, but that's definitely something we can look into.
Yeah, for sure. I think the point, though, is that the output is that this is the release surface area at the end. It's the thing we're working on now. Yeah. It's always latest. Then there are these supported releases, and we can decide how deep we want to go in that. And when we retire them, we can cap a release and say this thing no longer receives updates or service in some fashion, or it can be retired in some other fashion. But your point is well taken, that now we have that, and there's a structured way of understanding that those are supported releases versus some other random internal thing. Then it's about process and optimization. So I'm pretty happy with that. This is great. Thank you. And I'm going to have to go now read about release flow, I think. So I will try to keep myself up to speed on that. Thank you.
Awesome. Cool. Thank you. So yeah, let's move on to the merge loop operator, version 1.0. So a bit of background, what an operator is in the Kubernetes world. It's a custom extension that allows us to insert some specially running business logic into a Kubernetes cluster. So one example is perform backups every Friday. And another one, which is the one we're doing here, is check that the images of my running deployments or my running pods are up to date, that they're the latest, that they have the security patches that we just talked about. So this is, while the branching strategy is kind of like the process of doing this, the operator is the way that we see this being applied, and kind of applying those security patches and updates to running deployments of Moduloop in the future. So that said, we set us, I think, a reasonably modest goal for the Moduloop operator version 1.0. It has three purposes. One is it's going to scan the images on the running Kubernetes cluster regularly for updates based on a proposed upgrade strategy. So the upgrade strategy could be something like a bug fix. It could be something like a minor version. Say if you're running a development version of Moduloop and you're happy to go up to the latest minor version, then maybe you want to do that. Or even major version. If you want to make sure that you're always running the latest Moduloop, you wouldn't want to do this in production, but it could be very helpful for doing things like development and debugging. We want to alert operators of these available upgrades. So our method is just Slack at the moment, because that's nice and easy. We have webhooks for that. And then we want to be able to provide copy and paste based instructions. So the operator itself isn't smart enough to apply these updates to the running pods or deployments, but it's smart enough to tell you what you should do yourself, because we didn't really want to go too far, I guess, and make this like beast that was able to do all this orchestration without making sure we really understood the business need and make sure that people could really use it first in kind of, I guess, an MVP fashion. So one of the things that we need to do this kind of as a companion piece is something called, we're calling Image Watcher. And what Image Watcher does is you give it a list of Docker images that you want to watch in a Docker registry, and it will periodically ping or scrape from the Docker Hub registry and cache that in this list of images that it knows about. So this is non-Moduloop specific. This is something that we can kind of give out to the world. Hopefully it could be useful to some people, but once it's maintained this list of all the images, you can then query it and say, hey, I'm on version A. If I wanted to upgrade using this type of strategy, like a bug fix, like I said, or a minor version, what's the next image that I should go to? And that's essentially what it does. And the main reason for this was to get around rate limiting issues, and it's a very expensive call to be going to Docker Hub every time when it's something really easy to cache. So that's what Image Watcher is. We'll see a quick demo of that in a second. And then the Moduloop operator, really the only output that we can see as operators at the moment is these two types of Slack webhooks. Oops, there we go, top one. The top Slack webhook is to say, hey, everything's fine. I scanned all the images that you told me to scan, and we're looking good. The second one is what we said is an alert to say you've got some containers, or you've got some pods that aren't running the latest version based on the upgrade strategy you told me to look for. So here's a command you can copy and paste, and that will upgrade your deployments for you. So I think this is my penultimate demo of the day. And let me switch over to that. Once again, a video demo. I don't have the guts to do a live demo. I also don't have the number of computers with the different setups and environments and whatnot. So, okay, let's take a quick look. I think I can fast forward through a bunch of this. So the first part of our demo, let me know if you can't see the text. I know we've had problems with that in the past.
We can see it just fine.
Okay, cool. That's great. So in this example, this is just a demo of the Image Watcher server. So we can just ping it and say, I'm on Central Ledger v8.5.1, and I want to upgrade using the bug fix strategy. And oh, this has actually gone back to 8.5.0. Oh, okay, I think I was meant to skip that part. So ignore that. Let's see. So I think there was no 8.5.1 in this case, so just put me back to 8.5.0. So in this case, we sent the same request with the minor strategy, and that said, so that's going to be the minor the minor version here, and that said the highest minor version for the major version V8 is 8.8.5, so you can upgrade to that one. So we've got a few more examples of that. I think we get the idea. There's 8.8.1, which is what I meant to write. So the bug fix version for 8.8.1 is 8.8.5. There we go. And so the next step now is to just run the sorry, we're going to have a look. I have to remember what I did yesterday. Is list all of the deployments that are running in our Kubernetes cluster. So this is a simplified version of our Helm charts. This is actually the PISP example that we saw earlier. And so we have a bunch of different deployments. We have the account lookup service, we've got the auth service, and so on and so forth. And we have set our ML operator to look at these different services and let us know if any of them are out of date. And it's going to be some that are out of date because I set up this demo. And I just ran the operator in the previous section, which isn't that interesting to look at. But the interesting thing is the Slack notification we got here, at which point we can go ahead and copy the text and we can paste it in to our console, which is going to update the account lookup service and the auth service to the latest version. So we can do that, and it says they've been patched. So we can then actually monitor the pods that are getting created, so we can see the old ones, the new ones are getting spun up, and the old pods are getting destroyed as we go along. That's a throwback to the last PI, any who are playing along at home. That's all there really is. Nothing too interesting other than console windows and Slack. So I won't bore you with that any further. I think our final thing to talk about is our PI 12 objectives. These are, like always during the convening, we have an idea of what we want to do, but we're not quite sure yet. We talked about earlier in the PISP presentation about auto releasing, and that's something I'd love to do and bring in across the rest of our code base and to consolidate our CI/CD a little bit better. We want to do a 1.1 version of Modular Loop Operator, which is going to actually apply those updates. So you don't have to copy and paste those commands. And maybe we can even integrate it with some of the other UI work that's been done for hub operators. And also do something like an upgrade window. And finally, I think we did talk briefly about maybe trying to come back to some of our previous work with the zero downtime deployment proof of concept. And especially, I think getting feedback from Mawali or some other implementers would be really beneficial for us. And it's also something worth calling out. We've had Matt Kingston join us as well in the versioning stream. That's been very helpful to get a bit closer to the real world and less the theoretical world that we sometimes live in. I think that's all I've got. Sam, do you have anything else to add? Otherwise, I can throw up into questions, or we can do other stuff if Simeon would like.
Thanks, Luis. I think you covered it all. The only focus, I think we have all the standards in place. Moving forward, maybe our focus will be on the data migration to ensure that upgrades and the real world implementations have a smooth experience when they upgrade the latest release.
Yeah.
Thank you.
Cool. Cheers. And okay then, well, that's us. Thank you, everyone, and thank you, Simeon.